Good morning. In this video, we're going to be looking at inserting charts using Excel. And for the most part, these skills should be transferable over to Google Sheets. So let's take a look. We've got some data here, and it's asking us to create a frequency diagram and explain which sum is most likely to occur. And I'm taking some of the stuff from the previous lesson to try and create a chart. So here, I've got a sum, and a frequency is how often or how frequent a number occurs. Now what we could do is we can look at the sum of 2 in the chart above. We could say, okay, it happens once. Now another way we could end up doing this, and we could continue to count 2, but we could also use a COUNTIF function. COUNTIF, we can put in the range, and it probably will be easier for most people that aren't as comfortable with absolute cell references to do just the counting, but I just want to prove to you that we could do all of this if it was a much larger chart in a very short period of time. So we're going to count everything, and every time that we fill down, we're going to look at this information here. I need to go to the cell next to it, which is blocked. And we're going to say count it if it is the same as the sum in C12. So what it's doing is count this group of data if it's in C12, and then as we fill down, Control D, now it's counting C13, C14, and notice because we use these dollar signs that the cell references did not change. So how do we insert a chart? First, we need to select the data that we want to insert. So insert, and in Microsoft Excel, they've got a bunch of options. You could go to recommended charts and see what comes up. This one's fine. If you're not seeing what you want to actually input, you also have more options here. For example, you got bar graphs, and you've got, this is what we call a histogram. Differences being that with a histogram, there is there's no space between the bars. So a bar chart has space. I actually think that, and you can also click on more charts if you want to take a look. This is what we call a column or a bar chart. This is what we're looking for. Okay, we're going to insert, and now we've got our frequency diagram. So the way we would read this is the sum of the sum of 2 occurs twice. And you also have this ability to include axis titles. So this here would be the frequency, and this down at the bottom would be the sum of 2 die. Sum of 2. I think it's dice actually. So now we look at the question, create a frequency diagram, done, and explain which sum is most likely to occur. Reading the diagram, the 7 is most likely to occur. And if you've never seen this before, it's because it has the most number of combinations in terms of what the dice can sum to. So it could be sum of 6 and 1. It could be the sum of 1 and 6. It could be 3 and 4. It could be 2 and 5, 5 and 2. And so what we do start to see is that 7 will be the most common number that comes up. If you were to calculate this as a percentage, you would come up, well, 6 times 6 is 36, so it would be equal to 7 out of 36. I think we want to increase the decimal place, which would be 19%. So there's a 19% chance that it would show up as a 7. Moving along, the next question here, we've got create a pie graph that shows the expense as a percentage of the total and identify the expense and percentage of the highest expense. So this is used in budgeting. So let's take a look at what happens here. Again, we're going to select the data. We're going to go insert chart. We've got recommended charts. I wonder what will happen if we put this in. They do show a pie chart here. Sure, why not? Let's pick that one. So this one's looking at cost, and it's really nice because I've already put in a legend down here so it's clear as to what's happening. And of course we could have just looked up here and said, okay, well, we already know that rent is the highest, but it's asking for the percentage. So let's go see what our options are. Data labels. Okay, well, let's take a peek here. Can we find more options? So in the more options section, we have a whole bunch of options that we can end up displaying. So let's just click on percentage. We click on percentage, so now it will all of a sudden add both the value and the percentage. If we want to get rid of the value and just have percentages, we can do that. I wonder if what happens if we put category names. So we do have some adjustments that we can make, and so it depends on what you want to actually display. You have to make a decision of how you actually want to present this data, what makes sense to you, and you have to make sure that the text is big enough. Now here's one of the other cool things that happens in Excel is that if we were to change this to 80, your graph changes with it. So let's just go back to this question. Identify the expense and percentage of the highest expense. Rent at 43%. Done. Now, we're going to be looking at something called scatter plots in the next one, and this is going to lead into linear regression and nonlinear regression. So what we're going to do for this is we're going to hide these ones so we can slide this over and still see. So here I've got a whole bunch of data, and we need to see trends in the data. Right now it's just a big jumble and a big mess. So how can we actually create something so that we can see connections in the data? So in this question, we're asked to create 3 scatter plots that model x and y1, x and y2, and x and y3. So we're doing 3 separate graphs. So the first one is the easiest one because we can just drag over top of the data. But when it comes to selecting x and y2, well, how do we do that? And this is where you hold down the control key at the same time, and then you can drag over top of the cells that you actually want to have included. And we're always going to include x1. Holding down that control key allows us to select multiple cells in different columns. So let's just go ahead and do the first one. And go insert. This is what we call a scatter plot, and we can add labels to it if we want to. So this little plus symbol, axis titles, and this is where we would say, okay, this is y1. And of course, you're probably going to do a better job depending upon what the data is. This is x1, or just x, and then the title should be something like x versus x versus y1. Now, notice that this is about what we call linear regression. And in middle school, you would have learned something called line of best fit. Linear regression is something which is just mathematically calculated as a line of best fit. So how do we do that here? Well, we can clearly see that there's a positive trend. This is something that you would learn in grade 9 math. Now, you could also have said that you learned line of best fit in middle school, but how do we do that in an electronic environment? In here, you've got something called a trend line. So we click that. But we also have more options. Linear forecast. Let's take a look at what more options show up to be. So, where is it? Okay, so it's not in this portion. Let's take a look at over here. This here gives us a lot of different options to show models for the data. And we can say display equation on the chart. So this is what we call a line. And this is a linear regression, and we can see that it's a linear regression because linear, meaning a line, we are regressing the line onto the data, and we're trying to make it as close to the data as possible. So in this case, our model would be y equals 0.9181 x plus 0.1953. So this is just a line with a y-intercept of 0.953 and a slope of 0.918. So that's a positive number, indicates that the values are going upwards to the right. Let's see what happens when we end up going to do y1. Select x, hold down the control key, select y2, and we do the exact same process. Insert, except this is very spread out, and the data is what we call very far from kind of a line. We can still do a trend line. Let's try. Include trend line. Okay, we're going to do the exact same thing. I'm going to come back over here to more options. So pop out more options. Go to the graphs, and we can go display equation on chart. Now there's also something here called the R squared value. And the R squared value will essentially tell you how close the data is to the line that you've got going on here. And so if we were to have gone back up here and go trend line, let's go see more options. and put in an r squared value on there, that it's really close to 1. So what I'm trying to show you here is that when we want to try and describe data, this is something that we call correlation. And I've included this little bit of data, or this graph over here, pictures. This is perfect correlation, where if we drew a line through it, it would connect to all dots. High negative correlation, so it's going downward to the right, and that would have something like a value between -1 to -0.67. Now, I think, if I remember correctly, that r squared is looking at how well the data fits and is not as much about correlation, but it does have a connection. It just kind of ignores the negative values of it. If you wanted to calculate correlation of two values, you could do that as well. The r squared value will tell you how well this fits to the data. This data is very scattered from where this line is, and therefore it is not going to give you a very high r squared value. Alright, what is the model? The model in this case is y equals -1.0513x minus 7.219. So this tells us that it's a line. And whatever the data looks like, you're going to have to adjust what the chart looks like and possibly the model. Maybe you could find a better model than that. Let's go insert a new data, new scatter plot for the final one. And of course, I didn't update the titles or the axes titles here, but I hope that you guys would do that on a regular basis. This is clearly not a line. In fact, it goes down and then comes back up. And this is what we call nonlinear. So we're going to go to a nonlinear regression. So if I were to put in a trend line, it's not going to be very meaningful. In fact, it doesn't really fit the data very well at all. And we could actually do the r squared value, and you'd see that it's pretty much very close to 0. What we could do is, let's go to more options. And here, as you get into higher level mathematics, you're going to see that the trend lines, or the curves of best fit, will end up changing. So this is what we could call a polynomial. So this now all of a sudden is a polynomial, and this is partly why we get into more advanced mathematics, is because in the real world we start to model data. What are we going to predict if we're thinking about CO2 emissions? So I've at least shown you how to include a graph given multiple sets of data. I've shown you how to do a line and curve of best fit, and I've also shown you how to show what those equations are. So display equation on the chart. We could pop it in here and it'd be good. We also understand from this that correlation is how far spread out the data is, and that those correlation values could go anywhere between -1 and 1. Are you expected to know all of this stuff for the grade 9 course? No. But I'm at least trying to show you how we could connect this to the real world, and how the Excel can be a really powerful tool to analyze data and see trends in data and model it. And we could take this stuff and we could then start to predict what future values, in terms, or another way of saying would be extrapolate the data. That's all for now. I hope this is useful. If you have any questions, throw some questions up in the Google Classroom or email me. Thanks for watching.